Alright guys, so on the left I have exam 1 from the fall 2016 open, and I will just be going problem by problem. Here we go. A is equal to 2 by 1 to 5. In the first row, the second row is from -1 to -8 by -2. Well, first thing I would do on your guys' sheet of papers is I would just make the matrix. I have 2, 3, 4, 5. And then I have the matrix -1, and then I'm going by 2 here. I want these to line up. I don't know if they're going to. I have -1, -3 because I'm skipping by 2, -5, and -7. Now I don't include -8 because I'm skipping by 2. It's not going to work. So here's our matrix, and it's saying what will size A return when executing in MATLAB? Well, we didn't set size A equal to anything, so we know our default should be ANS. The size function returns how many rows and how many columns there are. So we can see that there are 2 rows and 1, 2, 3, 4 columns. So it should return ANS is equal to 2 space 4. And let me just put A in here. Hold on. So I typed in A and I pressed enter, and you see that these two matrices are the same. That's kind of just to prove to you that what I set up here was correct. And then if I say the size of A, I should get ANS is equal to 2 space 4. And that's it for problem 1. Let's go to problem 2. A new session of MATLAB is open and the following two matrices are entered. B is equal to 9, 8, and C is equal to 2.3, 4.5, and 2.5. This is the way that Peralta had it set up. That's the way Peralta wanted us to write it. So I need to clear A and ANS so that over here in my workspace I just have B and C, because he mentioned a new session of MATLAB is open. So here's a new session. I have B and C defined, and he says what happens when the user types in save B data and B. Well, here's what happens. When you type save in, you're asking MATLAB to save everything in your workspace. Now, he's saving it under the name bdata. So this is saying save everything in your workspace as a mat file. This is saying the name of my mat file is bdata. Now, if you have anything extra outside of that, you're just saying, hey, I need these variables saved. I need variable b saved. So if I type that over here, you'll see that bdata.mat shows up. And all it did was create a mat file. Now let me CLC and clear everything. If I open bdata up, we should only have variable b in there. Right here. And you can see that there's a faster way to do it. If you say load bdata.mat, it's the same thing as double clicking. But let's go a little further. M is equal to hello world, for instance, and O is equal to some random number. I have no idea. I'm just making things up here. L is equal to I can't do that. L is equal to this. I could say save mark, and all I want is B and L and M, but not O. So I saves as mark.mat. I CLC, I clear, and then I say load mark. Which if I come up here, say load mark.map, and B, L, and M are now given to me in my workspace. So that's what save B data does. Save, well, that's what the save option does. Save B data should say that it saves B into a map file named B data that is now in our current folder. Let's go on to the next one. If the user first enters the command len is equal to linspace -1032 into MATLAB, what will happen when the user enters length of len? Well, what happens when the user enters length len? It's not set equal to anything. So we know that our default variable is going to be ans equals. We got that far. That's half points, guys. And then we just need to figure out what this linspace means. And the way linspace works is it says, give me numbers between, in this first section, tells us our first variable. This section tells us our ending variable. And this tells us how many variables we want between the two. And so len is equal to linspace -1032. That's just saying give me two variables between -10 and 3. Well, give me two variables including -10 and 3. So these are definitely included. So when it only asks for 2, we know that the two variables that are popping out are -10 and 3. If I type len is equal to linspace of -10 to 3 by 2, we see that len is equal to -10 and 3. The question was, what will happen when the user enters the length of len? And remember that the length is just going to give back our largest dimension. So our dimensions here are, we have one row and two columns. So the answer should be ans is equal to 2, since that's our largest dimension. ans is equal to 2. Perfect. What is the default variable used in MATLAB when no variable is assigned? So just some random equation, 5 plus 5. We already know the answer. It's ans is always our default variable, but let me prove it to you. ans equals 10. Okay, let's go to the next one. This is a true and false question, and it says when you enter 3 by 16 2 in the MATLAB commands window, the response will be ans is equal to 3, 5, 7, 9, 11, 13, 15. True or false? Well, ans equals is our default variable, and since they didn't set it equal to anything, it would be ans equals as long as this thing was a real execute. Well, it could be executed as long as this doesn't work right here. We're saying 3 to 2 by 16, and that never happened. I don't know how that would ever happen. That's just silly. And so the answer here should be false, because the answer would be an error. Oh, I lied to you. Look at that. It's an empty double row vector. Well, that's cool. I'm not going back to correct my mistake. I'm just going to keep on going. Find the errors in the code, correct them, 2 points each. All comments are accurate, 10 points. Guys, I'm not doing this. I will do it during my office hours right before the test. So please come in and see me. We can practice this. Oh, no, please come in and see me. We'll practice that. Let's go over here. 6. So remember PEMDAS. This is the order of operations. We're first going to do the parentheses, and then so if we follow order of operations, we do parentheses first. 1 divided by 2 is 0.5. Then we do anything raised to any power. So 25 to the 0.5 is just the square root of 25, which is 5. Then we're going to do multiplication. 5 times 1 is 5. And then we can do addition and subtraction. 3 minus 5 is negative 2. Let's see. A and S equals negative 2. I would have got partial points on that one. Go on to the next one. So the numbers are the exact same, except we just rearrange our parentheses. We first do this part right here, 3 minus 1, which is 2. From there, we go on to any exponent. So 25 raised to the power of just 1. We're not doing to the 1/2. 25 raised to the power of 1 is just 25. So we have 2 times 25 divided by 2. The 2's cancel out, and we are just left with 25. However, what's going to be displayed to the screen is, since it's not our default variable a and s, it's x is equal to, we'll have x is equal to 25. Perfect. Let's move on to the next one. So the same thing applies here. We're going to follow order of operations, PEMDAS. We first do multiplication here. And I would do this on a separate sheet of paper, just so you know exactly what's going on. I don't know, it always helps me. So we're going to multiply 5 into this matrix, 2 and 1, and we'll get 10 and 5 coming out. Then when we have 10 and 5, we're going to subtract it by 2 and negative 1. And so 10 minus 2 is 8. I'm going to delete this. Let me just talk about it. 10 minus 2 is 8. And then 5 minus a negative 1 is 6. That's just 5 plus 1. And so the answer should be a and s is equal to 8 semicolon 6. Minus 2. A and s is equal to 8, 6. But know that it's a column, one column and not one row. Problem 9. So, order of operations again. Well, we only have one operation here. We have this matrix squared. Well, each element in the matrix is squared since we're using the dot. So we have negative 1 squared, which is 1, and then 0 squared, which is just 0. And so the answer should be a and s is equal to 1 and 0. Let's go on to problem 10. Again, we follow order of operation, PEMDAS. We do division first. 2 divided by 2 is 1, so we have the matrix 1. And then 4 divided by 2 is 2. Now, we say 4 minus this matrix. So 4 minus 1 is 3, and 4 minus 2 is 2. But we don't use the default variable. We have a is equal to 4 minus, or a is equal to, I'm sorry, a is equal to 3 space or comma 2. So let's write that out. A is equal to 3, 2. Do another one. Problem 11. B is equal to the sum of 2, 0 times negative 1, negative 2. Well, let's do this first. The sum of 2 plus 0 is just 2. So then we have 2 times negative 1 times negative 2. So 2 times negative 1 is negative 2. 2 times negative 2 is negative 4. B is equal to negative 2, negative 4. Let me write that out. So while I was writing it out, I just wanted to remind you what sum does if it's a multi-row, multi-column. It sums down the columns. So since here we just have one row, we're just going to sum the entire row. However, if it was a multi-row, it would sum down the columns. B is equal to negative 2, negative 4. Let's do the last one. 2 times 2, 1. 2 times the matrix 2, 1 raised to the third power. Okay. So again, we follow order of operations, PEMDAS. We're going to do the powers first. So 2 to the third is 8. 1 to the third is just 1. 8 times 2 is 16, and 1 times 2 is 2. So the answer would be A and S is equal to 16, 2. Let's keep on going. Now for these ones, I definitely recommend you get a sheet of paper, put it next to your test, and write these out so that you could see the matrix rather than just read it from one line. So I'm going to do that personally, and then I'll come right back. Alright, so what I did on my sheet of paper was I wrote something that looked exactly like this: 64, 4, 0, 1, and 36, 16. And I did that for X, Y, and Z. So let me do it here for X, Y, and Z, and then we'll come right back. Alright guys, so what I did is I entered in the matrices X, Y, and Z just by highlighting, copy, pasting in, and then I saved it into a mat file. That's iii.mat. That way, you know, it makes sense to me. I know where to go. The only reason I saved it into a .mat is because I'm really bad at saying CLC clear. It's a default of mine. So let's get going. The square root of x. SQ is equal to the square root of x. Now, there's no default variable here. Our variable is at SQ. And we have to take the square root of each one. So 64 squared is 8. 0 squared is just 0. 36 squared is 6. 4 squared is 2. 1 squared is 1. 16, not squared, square root. 16 square root is 4. So our matrix SQ should equal, SQ equals 8 space 2 comma 0 space 1 comma 6 space 4. Okay, I hope that was alright. Let's go round Y. CLC, we can say A is equal to round Y. I guess I should write it down before I just say it. Let's go back. Round Y. So we're rounding Y. And remember, 0.5 and above goes to the next number. 0.5 or anything below 0.5 goes down. I think you guys know how to round. I have faith in you. And we're setting this equal to A. So let me see what. Oh, that's not going to work for me. Alright. So here I'm going to say A is equal to, and lucky for us, it's just one long row. Negative 2.27 rounds down to negative 3. 1.23 rounds to 1. 0.67 rounds to 1. negative 4.55 rounds to negative 5, and negative 0.3 rounds to 0. So that's my guess. Now let's see what it really is. Negative 2. Oh man, I'm not redoing this video. I don't know what I was thinking right there. That's silly. And I definitely would have counted myself off for that. Rookie move, Mark. Rookie move, dude. Let's do the ceiling. Now remember that the ceiling rounds to positive infinity. So no matter what, everything is going to positive infinity. B is equal to going to the right to right. Oh, I'm thinking of a timeline. I have negative 2.27. I'm going towards negative infinity. It's going to the right. So I'm saying negative 2. It's a 1205. Negative 2, 1.23 goes to 2. 0.67 goes to 1. Negative 4.55 goes to 4. And negative 0.3 goes to 0. That is my guess. B equals this. And let's type it in. B is equal to the seal of y. Negative 2, 2, 1. Oh, I forgot a negative 4 right here. Sorry, guys. And 0. Yeah, I probably would have counted myself off right here for that too. I'm missing points. I'm just kidding. I probably wouldn't. If you guys miss, as long as you get the majority of them, you get 2 out of 5. That's the correct answer for me. Let's see what x is. So we say x colon primed dot times z. Well, when we dot time something, we need to make sure that whoa, we're just finding out what it prints out. So we need to make sure that this isn't an error first. As long as x and z are the same size, then nothing will print out. However, if they're not the same size, an error will print out. So what is this? 1, 2, 3, 4, 5, 6. That's a 1 by 6. Perfect. And after we say z colon, which puts it all into one column, and then we prime it, which means it's all in one row, we have 1, 2, 3, 4, 5, 6. And since they are the same exact size, it's a row times a row, I am predicting that nothing will print out. Nothing. That's what you have to write, nothing. Don't just leave it blank, because then I feel like you don't know the answer. Colon prime dot times z. Suppressed. And up here in my workspace, you'll see A and S pop up. However, in my command window, nothing will be displayed. There's A and S, and nothing is displayed. So, thank God we didn't have to do all that work. We just had to make sure that X and Z were the same size. Let's keep on going. Did he change Z up on me? He did. All right. Let me rewrite Z now. Hold on. So I wrote Z on my sheet of paper exactly like this, and I just redefined Z here. And so I should probably save it. Save as I_2, and now it's one. Save it, and man, I should. You know what? Let me delete that. Delete. I'll pause. You guys are going to see this. I_2. You have to find a .mat. I have to say .mat. You do have to say .mat. So I want to clear everything except for, looks like except for Z. Oh yeah, I just need to save Z. So you just say save Z. CLC clear. Then I could type load, but it's faster just to do this. And then I want to know what Z is, and that is correct. We're ready to go. I'm sorry. This is where Peralta messes with us. I know that, I'm sorry, we're on problem 17. Let's just have this up on top. We have max of z, comma, location of said max of z, and that is equal to the max of z. I'm just going to write that down. That is my template for me, and for you guys to have too. This is how it's set up. This first slot is reserved for the max. This second slot is reserved for the location, or actually the row that the max is in. I don't want to say location because it's not by position. It's just the row that it happens to be in. And so let's see z. It's asking us what is the max of z. Now, all of MATLAB is column based, so I should get two maxes out right here. I should get the max of the first column and then the max of the second column. The max of the first column is 4, and the max of the second column is 2. And it's saved as A. So my prediction is A is equal to 4 space 2. Well, there's going to look like this. Well, I can't do it. A is equal to 4, 2. That's my prediction. If I say A is equal to the max of Z. I was right. That's good, because I didn't want to have to start this video over. Let's do max of Z prime. So here's Z, and we gotta do Z prime. So I'm going to write Z prime on my paper really quick. I'll pause the video, and then, well, we can do it together. Remember, when you prime something, I say prime, it's transpose. So our rows become columns, and our columns become rows. So Z underscore P, or T, let's say Z transpose is equal to -2, 0, 1. I'm sorry, what am I doing? It's 3, 3, 4, 3. And I gotta put bracket in here, 3, 3, 4, 3. And then it's going to be -2, 0, 1, and 2. That's what Z prime is going to be. And I'll show you right now. And so let me write Z prime on my paper really quick, because that's important. So I'm just going, I don't know why I have Z. I'm sorry. Let's bring back my, yep, there we go. I would write this at the top of your guys' paper so that you remember it no matter what, because he's going to try to trick you. We have K and we have val. And these are just random variables that he picked. K and val is equal to the max of Z prime. So let's look at Z prime again. Well, K is going to be the maximum of Z. Or here, in our case, it's going to be Z prime. And so our K value should equal to the max of each column. So we have 3, 3, 4, and 3. That's K. Then we have V. And V is going to be equal to the location. Well, the row of each max. So here it's 1, 1, 1, and 1. And let me comment this out. This is the answer. This is what I believe will pop up. K equals 3, 3, 4, 3, and V is equal to 1, 1, 1, 1. Let's do it. I'm pausing it while I type just to trim down on the fly. Guys, right here it should say val. Before I execute it, this should say val. You know what? I got this. Check this out. Control C. Then I'm gonna come up. This should be val. I'm sorry. You know what? CLC. Don't clear. And then go up. I believe the answer to be this. In my heart. I might get it wrong. Oh. Well, I need that too. Control V. Okay. Moment of truth. 3343 and val is 1111. Perfect. Let's move on to the length of z colon. So remember what z colon does is it puts everything into one long column based on the position number. So let me show you what z is. If we count it here, I hope you guys can see my cursor. This is position 1, 2, 3, 4, and then this is 5, 6, 7, 8. When I say z colon, it's going to throw this whole column on the bottom of this one. And now it's just going to be one long column. And let me show you that a little bit. Now when I say the length, I'm just taking the largest dimension. And here, we have, I don't know how many rows we have, but we have one column. Our rows are 1, 2, 3, 4, 5, 6, 7, 8. So we have an 8 by 1 right here. The largest dimension there is 8. So length of z colon is 8. ANS equals 8. So let me just put my prediction down. ANS equals 8. And then I could say length of z colon. That's not how you write it. There we go. ANS equals 8. Perfect. CLC. And no, I won't clear anything. The product of z prime, colon. So here's z colon. We have to multiply that all out. Oh man, that's tough. That's tough cookies. Remember what the product does is it says 3 times 3 times 4 times 3 times negative 2 times 0 times 1 times 2. Lucky for us, Peralta threw in the 0 right here, and so this portion inside of this is just 0. And 0 times 3 is 0, and so my prediction is b is equal to 0. B is equal to 0. That's the answer that I believe to be true. And I say 3 times the product of z colon. Perfect. Let's keep on going to 21. The size of z prime primed. Oh man. Okay. We already have z prime in here, and I already have it written down. Z prime was 3343 as my first row and negative 2012 as my second row. I have that written down on my sheet of paper. If you guys did not do that, it's imperative that you do. However, let me prove it to you here. Now, we take the size of this, which is, taking my cord, which is 2 rows, this row, and then this row, and then 4 columns. Oh, that doesn't work. 1, 2, 3, and 4. So the size of that is a 2 by 4, and I'm writing this down on my paper. I should show you what I'm writing. So I'll try to type it out. I just did the size of z prime is equal to 2 by 4. That's what I wrote on my paper. Now on my paper, what I'm writing is the prime of that, and remember, it's just going to be 2 space 4. I put 2 by 4 on my paper, but really it's the matrix 2, 4. I know that to be true. And then if we prime 2, 4, we're going to get 2 and 4. So my prediction is S is equal to matrix 2, 4. I forgot which one we were doing. Oh, 21. How did I do that? Hold on one second. So here it is, moment of truth. X is equal to 2, 4. Perfect. Let's keep on going. Sort. It's important to note, let me go back to this one, that always do the function first. Do what's inside of the function first, then do the function, and then anything outside of the function, which was primed. So we did this first, and that was equal to 3, 3, 4, 3 on the first row, and negative 2, 0, 1, 2 on the second row. We took the size of that, which was a 2 by 4, and then we primed the matrix 2, 4 into 2 rows, 1 column, 2, 4. And so the answer was 2, 4. Okay. We're going to do the same thing here. Work on the inside first. So the colon, which puts everything into one long matrix, and I'm going to do that on my paper. Well, it's silly because it doesn't show you guys anything. So on my paper, I'm writing, God, it's faster to just write it on my paper, but let's do it here. Z colon is 3, 3, 4, 3, negative 2, 0, 1, and 2. That's what I have. That's for Z colon. And I'm sorry. Now I say sort. So let me sort it on my paper really quick now. So when we sort it, remember it starts from least to greatest, and it's going to be a column. I'm just going right. Negative 2, 0, 1, 2, 3, 3, 3, and 4. That's it sorted, and then I'm priming that, so I'm putting it into one long row from negative 2, 0, 1, 2, 3, 3, 3, and 4. And the output should be A and S equals. This is my prediction. And I did this all on a separate sheet of paper, guys. Don't try to do it right here. It looks that's going to be impossible for your TA to grade. Just get a separate sheet of paper and staple it, or just turn it in with your test. Let's do it. Sort Z colon prime. And it's this, but let me undock it so that you guys believe me. Then let me blow it up. Then let me rerun it. So you see that this is the same thing as this. Perfect. Let's do B is equal to Z end, comma, Z of end, comma, end. Okay, so what we need to know here is, let me see, I'll see this. We need to know how to pull out from the matrix. It's going to be your rows first, then your columns. And I would also write this on the top of your guys' papers. This is going to save you. So when he says B is equal to Z of end, B is equal to Z of n, comma, n, he's saying the very last row in Z and the very last column in Z. So where's Z? Here's what I'm doing on my paper. I come over to Z. Be sure not to mix Z up with Z prime. You guys need to have that properly labeled on your paper. You don't want to get confused. So I take the very last row, which is 3 and 2, and then the very last column, which is just intersects at 2. And so my guess here is that b is equal to 2. When I say b is equal to z, I don't know why I do that, z of n, comma, n. Perfect. Let's keep on going. Oh, these are exciting. Guys, the way to do these ones right here is to just flood your paper with parentheses. Remember PEMDAS, right? Well, parentheses is the first thing that you have to do no matter what. So what I would do is just flood your paper with parentheses. I'm probably not going to go back to check. I shouldn't tell you that because Peralta might be listening, but I don't think that he's committed to watch 41 minutes of a review to catch me. Well, I'd tell him anyways, but here's what I would write. Let's figure out the answer to this first. -2 minus a -1, that just turns into -1, and then 5 times 4 is 20, that's negative, so it should be 1/20th. That's what we're looking for. 1 divided by 20 is 0.05. What I would do, guys, is just flood it with parentheses. I have -2. There's no rule that you can't use a ridiculous amount of parentheses. So this is just the top part, and I put the whole thing in parentheses right here. Divided by, start my parentheses. I have -5 in parentheses. Then I have a multiplication. Then I have more parentheses, 4. And then I close my parentheses. And that's all you have to do. You want to try another one? This one looks brutal. Let's figure out the answer for it first. Words. So we have I'm doing it on paper, guys. We have 1/2 times 3/4, which is just 3/8, divided by, sorry guys, so we have 1/2 times 3/4, that's 3/8, divided by -3 to the -2. To the -2. Minus 2 plus 5, which is just 7, times 3 minus 4, which is just 1, -1, divided by 2 to the third. I guess we really don't need to know the answer to this. What's important is that we know how to write it. So let's do the numerator of the first one. We're going to be doing 1 divided, well, start out with parentheses, and then I say 1 divided by 2, close those parentheses, and then I say multiplied by 3 divided by 4, close those parentheses, and then close the top one. That's the numerator of the first. Let's do the denominator of the first, which is negative, and then 3 raised to -2. And this is the denominator. Did I throw an extra one in? No, I didn't. Then we're subtracting this by, that's right here. So let's do the numerator first. Start out with one big parenthesis. Say 2 plus 5. 2 plus 5. Multiplied, another parenthesis, 3 minus 4. This is the numerator of the second one. Let's do the denominator, which is just 2 to the third. What's important to know is that you guys don't have to know the answer here. He doesn't want you guys doing anything. Indicate what you would type into the command window for calculating or performing the following. It says, do not change fractions to decimal values. do not combine terms, etc. So this is all that we would type. And then press enter, negative 2.5. That seems reasonable. So the rule here is just always just flood your paper with parentheses. I don't know if your TA is going to go in and make sure that you did, but if my students flood it with parentheses, you guys are going to be perfect. It's going to be okay. As long as you don't say like 0.5 instead of 1/2, because then I have to take off points. Let's go to 26. Create a matrix C of 10 evenly spaced values from and including negative 14 to 7. This is perfect linspace. All you guys have to do is say linspace, first variable to the last variable, increment, and having 10 evenly spaced values. That's linspace. So you guys don't have to write the values out, you just have to put what you're going to have in MATLAB. And here it says create a matrix C. So I have to say C is equal to linspace. Create a matrix D of values decremented by 3 from 10 to 36. Well, start out D equals. That's like half the points right there, guys. And I say from 10 by negative 3 to negative 36. And that's it. That's all. Oh. You guys don't have to say what the values are. You just have to put this one line of code in. Create a 4x4 matrix of random values that are between 3 and 1/2, or 3.5 beginning value, 3.5, and 4 ending value. Well, if you're in my lab, you should remember this. We have a alright guys, so I'm sorry, I forgot where I was at. Problem 27. The format that you guys need to follow is this. We always do the delta, that's delta, delta times the random sum matrix plus the lowest number. That'll make more sense when we get started. So here we have, I'm sorry, 28, not 27. Here we have a 4x4 matrix, so we know that we're using random of 4. We need our values between 3.5 and 4, so our delta is 0.5, so we multiply that by 0.5. And then we add the lowest number, and our lowest number here is 3.5 plus 3.5. And so the way that this works is, let me explain it here. You have values between 0 and 1. When we multiply that by 0.5 times 0.5, we now are getting values between 0 and 0.5. And then when we add 3.5 to that, we are now getting values between 3.5 and 4. So that's one way to go back and check your work. So the correct answer to this is 0.5 times random of 4. We could just leave 1 4 in there. That means 4 by 4. Or we could put a comma and say 4, 4. Both of those are equally correct. Plus 3.5. And that's the answer. All you guys have to put is this one. Alright guys, problem 29. Create a 2-column, 3-row matrix with the value of 2 in all the positions using one MATLAB command. Well, there's a few ways to do this. We could use the ones function. Ones, and it wanted a 2 by 3. No, a 3-row, 2-column, 3-row, 2-column. And then all we do is add 1 to it. Another way to do that is to use zeros, 3 by 2. Oh, zeros plus 2. Sorry. And then lastly, if you guys forget zeros and ones, you forgot that function. It's not wrong if you just say 2, 2, 2, 2, 2, 2. Next, I am going to write down G, H, and I onto a separate sheet of paper so I could see what the matrix is, and then I'll put it into the computer and I'll come back. Hold on. Okie dokie. So, load IV. And now I have G, H, and I set up. Now for this, we're going to use two ways of pulling out values from a matrix. We're going to use our position, which is the matrix M by position. Then we're going to use by row and by column. That's position M, row, comma, col. So assign rows 1, 2, and 4 of the last assign rows 1, 2, and 4 of the last column of H to x1 and convert x1 to a row vector. So let's see what H is. That's what I meant. Assign rows 1, 2, and 4. So these first two, and then this one, of the last column of H. Oh, so he's saying 2, 4, and 8 to x1 and convert x1 to a row vector. Okay, so the way that we do this is on your sheet of paper, you're going to circle the numbers that you need. So on my sheet of paper, I circled 2, 4, and then I circled 8. This one, this one, and this one. So first I'm going to use this. Instead of M, I'm going to use H. And it asks me to set it equal to x1. So x1 of H. x1 is equal to H of, now the rows that I need are rows 1, 2, and 4. And it tells us right here 1, 2, and 4 as well. So 1, 2, 4. And the column that I need is the last column. The final column, the end column. You guys can put 3 there, or you can put end, it doesn't matter. And that is it for this one. Oh, no, it's not it. I'm sorry, I lied to you. Convert x1 to a row vector. So we say x1 is equal to H of 1, 2, 4, comma, end, and then prime it or transpose it to put it into one long row vector. Perfect. Assign the last 3 rows of the second column of H to x2. So let's see what H is again. The last 3 rows, 1, 2, 3, of the second column, so it's -1, 7, -5, to x2. So here we have x2 is equal to, now let's circle them on our paper, the one that we need, and then we'll see which rows we need. So we need rows 2, 3, and 4. But the way that he words it, he says the last 3 rows of the second column. So I know that it's just going to be, if there's 4 rows total, I could say 2 through end. Or, yeah, I'm going to stick with 2 through end. That's probably what I would write. And then at the second column, I mean just column number 2 to x2. And we get -1, 7, 5, -5, -1, 7, -5. Perfect. Assign x4 to the first 10 values of H. Alright, so we're going to use this one. M of position. And it says the first 10 values, and by that he means the first 10 positions. X4 is equal to H of 1 through 10. There we go. Let's go on to 33. CLC. Clear. Shoot, I did not mean to clear that. Oh man. Load, what do I call it? 4. Alright. Print out, that's why I saved it as a map file, guys. It's default for me to CLC clear. Print out the value 10 from matrix H by accessing the specific location within H matrix. So let's see what H is. I see the value 10. It's in the third position. So I say H of 3. They want to print out the value 10 from matrix H by accessing the specific location within H matrix. That's what it means to do. And S equals 10. But all you guys have to write is H of 3. Find H of I of G of N. Wow, that's brutal. But let's do it together as a unit. So first I need to see what G is. That's what I meant. The last value, G of end, is equal to 6. And so I, let's see what I is. I of 6 is 1, 2, 3, 4, 5, 6 is 2. And then H of 2, let's see what H is. 1, 2. H of 2 is just 2. So the value is A and S equals 2. Let me prove that to you. H of I of G of end. A and S is equal to 2. And so the first thing that I did is I said, what's G of end? And if you guys don't understand what's going on here, it's just this. It's a matrix by the position. So they're calling out a position right here. And you could have a bracket right here. Oh, I can't do that. Sorry. You could have a bracket right here, and you can see that's the same thing. So the first thing that we do is we evaluate the inside. And G of end was 6. And then you have I of 6. And I of 6 was 2. And then you have H of 2. And H of 2 is just 2. So A and S equals 2. Here we go. Create 2 new two-dimensional matrices using the two vectors I and G using the meshgrid function. So there's only one command here, and he's just asking us to use meshgrid by making 2 new two-dimensional matrices. It might be a lot of words, but all we have to say is new underscore I, comma new underscore G is equal to meshgrid of I and G. Then we get a new I and a new G. He's not asking what the new I and new G is. He just wants you to use meshgrid like this. He wants you to know that you guys know this function and how it works. So right here, you could have named, I didn't have to name it new I or new G. I could have named it apples and bananas. It didn't matter. But what is important is that this I, this new I, goes to this I. So the first value here is representative of the first value here. The second value here is representative of the second value here. As for 39, 40, and 41, I will be doing that in my office hours along with finding the error. So please come and visit me or try it yourself, and then if you can't figure out, come see me. My office hours are Friday. I can't spell. What's going on? Friday. Let me open an editor so I could write this. It's Friday from 10 to 12. You know what? 10 to 1. Because you guys have a test at 1. I don't mind doing that. It's in the ESS the ESS department. And it's in the computer pod. Across from Peralta's office. This is true, guys. The ESS department is in Centennial. It's the second floor of Centennial. So I will see you there this Friday from 10 in the morning to 1 in the afternoon. And thanks for watching.